All right, guys, so now that we've reviewed how to find the charges of our ions, let's just briefly review how to, number one, determine the formula from the name that's given to you, or determine the name from the formula of ionic compounds. Now, this is just a review of ionic compounds. We're going into covalent compounds later, but we got to make sure we get this before we move on. All right, so number one is calcium chloride, okay? So calcium chloride, and now this one is going to be a little bit easier. So whenever you're given the name of an ionic compound, the first thing I want you to do is look at the ending of the second part, right, of the anion. So this one ends in IDE. This is going to be an indication that this is going to be just two elements, one cation and one anion, right? So this is not polyatomic, so you do not have to use your polyatomic chart. Now, remember the exceptions are hydroxide and cyanide, but those are the only two. So calcium chloride is definitely going to be a just two elements, calcium and chlorine. Remember, when we name, we drop the ending and change it to INE. So calcium chloride, let me check my table really quick, find calcium and chlorine. So calcium is in group 2, so calcium is going to have a 2+ charge, and chlorine is in group 17, which means it's got 7 valence electrons, which means he wants 1 electron to fill up his octet, so he's got a -1 charge. So calcium is 2+, chlorine is 1-. So let's go back here. So we're going to have our calcium, which is 2+, and then our chlorine, which is 1-. And I'll go ahead and write the elemental symbols. Okay, now we're looking for the formula, so this is where we swap, drop, and chop. Remember, we swap our charges, right? And we drop them to the other side, and we drop those charges. So the 2 superscript for calcium now is going to become the subscript for chlorine. The 1 superscript for chlorine is going to become the subscript for calcium. Now remember, we do not write the 1s because the 1s are assumed, so we don't have to write a 1 for calcium. But for chlorine, we do need that subscript because it's 2. So calcium chloride, the formula for that would be CaCl2. Okay, so again, that comes from finding those charges. If you still don't know how to find the charges, hopefully you watched the video before this one, but if not, go back and do that. Okay, so CaCl2 is going to be the formula. So now let's do copper 2 phosphate. Now copper is a transition metal. And remember, with transition metals, the 2 tells us the charge, right? So I'm going to go ahead and exit this drawing because I know it's going to delete it. But we know that the charge for copper is going to be 2+. Now, here, again, we're looking at the end of this second portion of this name, which is 8-phosphate. Because it ends in ATE, remember 8 or ite is going to be indicative of a polyatomic. So let me go find my phosphate really quick. Remember, we got to get that from our polyatomic table that you guys have linked all the time. So remember, we had to find it in here and find the charge. So let's find our phosphate, which is, let me find it really quick. Right here. So phosphate, I know it was over here on this side. So PO4 3-, that's going to be the formula. So PO4, remember, we can tell that it's polyatomic because it's got phosphorus and oxygen. Remember, polyatomic anions have at least 2 capital letters in them. And then the charge is 3-. So let's go back and do this example. So we've got copper, which is, again, 2+. We know it's a plus because copper is the metal. Metals always donate to become the cation. And then for phosphate, we will have, remember, we're going to put him in parentheses, PO4 And I apologize for my terrible annotation skills with the mouse. And then this is a 3 minus. And now let's swap, drop, and chop. Now remember, for our polyatomics, we treat them as one unit. We don't break them up. So we're going to leave that phosphate, that PO4, just as he is. So that would be Cu. Now we're bringing this superscript to be the copper subscript, so it's Cu3. And then our polyatomic stays as is, so PO4. And then this superscript of the charge becomes the subscript. So our formula for copper 2 phosphate is going to be Cu3 PO4 2. And again, we leave the PO4 in parentheses because he's a polyatomic and he stays together as if he's one unit. And this would be your formula for copper 2 phosphate. Sometimes students get confused because it's copper 2 and then here's copper 3. The 2 refers to the charge. Okay, so the Roman numerals with transition metals always refers to the charge. Okay, so there is examples for figuring out the formula from the name of an ionic compound.